Good day everyone, I'm Torres Jeremy Urquia. Today is my report and I'm the last reporter in part 2 module 8 in IE2. My topic is all about retrofitting. General guidance in retrofitting. What is retrofitting? In refrigeration and air conditioning, retrofitting means the procedure of replacing ozone depleting substances or ODs, hydrofluorocarbons or HFC refrigerant in existing AIMs with zero ozone depleting potential or ODP, zero global warming potential or OWP refrigerant. Retrofitting usually requires modifications such as change of lubricant, replacement of expansion device, or replacement of compressor. The process of retrofitting from a system using ODs to an ozone-friendly refrigerant requires a thorough investigate and study of the system. Retrofitting is a deep process that can help refrigerant plant accommodate their environment control needs. So the technician is to refer to manuals and consult with manufacturer of refrigerant and compressor and study the characteristic. So sinasabi dito na dapat kumonsulta ang mga technician sa mga manual or kumonsulta sa mga manufacturer ng refrigerant compressor at magsaliksik ng mga katangian at iba pang mga bahagi ng system. Here's the factor to consider in retrofitting. First is retrofitting the system if it is more cost effective than replacement. If a major repair like compressor or modification of a system using ODs is necessary, it shall be evaluated if retrofit can be done at acceptable cost. Second is proper working and leak-free system are not recommended for retrofit at least until there is a need to open the refrigeration system for repair. Proper operating system can continue operating for many years without causing harm to the ozone layer. For our older system that are prone to errors, failures, and leaks, maaaring mas matipid na palitan ng mga system kaysa sa pag-retrofit. In additional, ang mga bagong kagamitan will be more energy efficient. Third is a fun evaluation of a system that requires major repair and is close to the end of its technical or economic life. Consider replacement if it is more cost effective than retrofitting. Fourth is the safety and environmental properties of the alternative refrigerant to be used, such as flammability, toxicity, ODP, or ozone depleting potential, and global warming potential, GWP, shall be considered. ODP or ozone depleting potential is a measure of how much damage a chemical can cause to the ozone layer. Fifth is include in the assessment the compatibility of components and materials in the system, such as elastomers and oil. Also, components like sight glasses and oil separators must be checked for suitability. 6 is assess and examine the operating condition of the system and determine service and its operational history. Here's the safety tips in retrofitting. First is never mix refrigerant in a refrigeration system or recovery cylinder. Any refrigerant mixing creates a non-reclaimable mixture that will cost you or your customer more in disposal fees. Second, never leak test a system using air, oxygen, or other oxidizing materials, because when our combining this HFCs and HFC hydrocarbon blends under pressure ay magkakos ito ng sunog or masusunog ito. Third is always read the MSDS or level and material safety data sheet before we working with a refrigerant. That is a most important tips in retrofitting. Fourth is never top off a system with a refrigerant other than what is already in that system. If you are not sure what is in a system, either recover the full charge or have the refrigerant tested. Fifth is always make sure the system you work on are properly labeled with a refrigerant and oil when you leave. Six is do not store refrigerant cylinder in direct sunlight or in areas where temperature ay mayroong 125 degrees Fahrenheit or 51.7 degrees Celsius. 7 is keep smaller cylinders from becoming a hazard by keeping them in their cartons while storing or transporting them. Always recover the contents of non-refillable refrigerant cylinder to 0 PSIG or less before disposing them. Whenever possible, recycle non-refillable cylinder at a local metal recycling center or scrapyard. Refrigeration and air conditioning system have their own specific characteristics, hence retrofitting them need to consider various characteristics of the system and the refrigerant involved. So if you can see this figure flow of work for retrofitting of CFC refrigeration equipment, general retrofitting process flow for refrigeration and air conditioning system. The manual for refrigeration services technicians specify the general retrofitting. Number 1 is record the baseline performance data of the system. So before we making any hardware changes, compare current system operating data with normal operating data. Correct any deficiencies and record final data as a performance baseline. Data should include temperature and pressure measurements throughout the system, including the evaporator, compressor, suction, and discharge, condenser, and expansion device. Those measurements will be useful when adjusting system with an alternative refrigerant during the retrofit. Second is pump down the system and recover the refrigerant. So, recover the refrigerant before opening the refrigeration system. Recovery of refrigerant shall be done using a recovery machine or a recovery and recycling machine operated only by a qualified technician. Exert all efforts to ensure the prevention of refrigerant emissions during the recovery operation. Number 3 is store recovered refrigerant. Store only in a specified refillable container or cylinder and properly labeled. Recovery means transferring the system refrigerant into a refillable refrigerant cylinder. If the refrigerant was not contaminated by a pneumatic motor burnout or other cause, it may be of adequate quality to be charged back into the system after the repairs are completed. Number 4, know the recommended CFC or HCFC charge size for the system. If it is not known with the entire amount of refrigerant, this amount can be used as a guide for the initial quantity of replacement refrigerant to be charged into the system. Number 5 is check the compatibility of the refrigerant to be added to the system with the existing oil. If the existing oil, typically a mineral oil, is incompatible, then it must be removed Otherwise, this state can be ignored. Drain and recover the existing mineral oil charge. Measure its quantity and compare with the recommended oil charge to determine the quantity of oil left in the system. Here's the question. A major problem with retrofits is removing the residual mineral oil, because if enough mineral oil is not removed, it can deposit on the evaporator heat exchanger surfaces, severely regarding performance. Since many small hermetic compressors do not have oil drain, removal of the compressor from the system may be necessary for draining the lubricant. The best point in the system to drain the lubricants is the suction line of the compressor. Small hand operated pumps are available. In checking the compatibility and retrofitting, before we retrofitting a system, we will have to assess the components to ensure it will be compatible with a new type of refrigerant. Remember that most of the mineral oil must be removed from the system before adding the replacement lubricant. Number 6. Replace all equipments, components, and accessories. All our all our equipments, components, and accessories such as expansion bulbs, gasket, filter dryers, etc., that will be affected by the new alternative refrigerant, and the refrigerant oil suitable for the new alternative refrigerant must be replaced as recommended by the manufacturer. Most of CFC or HCFC system with expansion bulbs will operate satisfactory. However, it may be necessary to adjust the superheat. If the system uses a capillary tube, it will need to replace with one of greater or lesser restriction in order to achieve satisfactory performance over the complete range of design condition. It is recommended that the technician consult with the equipment. Number 7. Charge the system with new and correct amount of alternative refrigerant oil. Do as recommended by compressor system manufacturer. Number 8. Reinstall the compressor. Follow the standard service practices recommended by the manufacturer. If an oil pump was used to remove the oil, reseal the access port. Number 9. Run the system while performing the oil change procedure. So, run the system as many times as necessary until the mineral oil in the system does not exceed the recommended 5% acceptable level. Generally, it will require about 3 charges to get the mineral oil content down to the acceptable level. Test kits are available from several lubricant suppliers that check for residual mineral oil content. And number 10 is test the system for leak. Use oxygen-free dry nitrogen in leak testing and observe in 1D standing pressure. Make correction if deemed necessary. Number 11. Evaluate or vacuum the system. Use an appropriate vacuum pump and an electronic vacuum gauge to vacuum the system to at least 1000 microns 1 MBR. Use normal service practices to reconnect and evaluate the system and to remove air and other non-condensable contaminants. Number 12. Charge the system with an appropriate amount of alternative refrigerant. when charging the system with alternative refrigerant, use the same charging procedures that you should use for CFC or HCFC to ensure optimal system performance. In general, system will require a smaller charge size than those using CFC or HCFC. If the original capillary tube is used, it will generally be necessary to undercharge the system to prevent liquid flood back to the compressor. Special care should be taken when charging with refrigerant blends. Number 13, run the system and charge additional refrigerant if needed until fully charged. The use of expansion device not optimized for the system, such as the original capillary tube, will make the system more sensitive to charge and or operating conditions. As a result, system performance will change more quickly if the system is overcharged or undercharged. Number 14, monitor the system operation and performance. So, run the system for at least 48 hours or longer to monitor its operation and performance and make necessary adjustment if needed. Number 15, check remaining content of mineral oil. Using a refractometer or oil test kit, check the amount of mineral oil remaining in the system. Number 16, follow the system and or compressor manufacturer recommendations. Always refer to the compressor manufacturer's recommendation as tolerance is dependent on the system and its operating conditions. Number 17 or last number, level the system. After we retrofitting the system, we need to level the system components to identify the refrigerant and specify type of lubricant by brand name in the system. This will help to ensure that the proper refrigerant and lubricants will be used to service the equipment in the future. And that's all for general retrofitting process flow for refrigeration and air conditioning system. Thank you.